Hi, my name is Dave Edelhart. I work at Leap Motion. I'm an avid Node enthusiast, and I've brought some people from Shasta who have been working in Selenium to test the Leap Motion application to back up my relatively limited knowledge of the subject I'm about to speak on. Want to introduce yourself?
I'm Chris from Shasta QA. Been working with Selenium, WebDriver mainly for a couple years now, on a multitude of different projects. So, yeah. Turn that back over.
Sure. I'd like to kind of gauge the metric of the room. How many people here use Node.js in their job or personal life? How many people here have used Selenium or written tests for Selenium? And how many people in here reflexively raise their hand at the end of every sentence? Oh, yeah, well, you got problems. Okay. This talk is based in large on some work I did at a startup I worked at previously, in which there was a lot of problems controlling the data flow that went into the tests, and it required a complete mock-up of their backend API in order to provide consistent REST data into the app in order for Selenium to provide consistent results. And I also found that Selenium, Node doesn't work well just to do like backup, do REST applications. It also works quite well to drive the tests themselves. The basic pipeline that Selenium works through is you write a test, you use a API, WebDriver usually, to communicate to a Selenium server which is running as a standalone daemon. The server opens an actual browser, Chrome, Firefox, and it sends commands to the browser that emulates the sort of activity a user does when he uses the browser with a mouse and a keypad. This includes filling out forms, clicking on links, clicking on buttons, changing the URL text of the browser, so that your tests can say, from a black box point of view, this is how your web site responds to actual user interaction. Could have put that up, I suppose. I'll give you like 8 seconds to get the snapshots of the URLs of the presentation, and we're off. Selenium tests can test any sort of web application. The web application doesn't have to be written in Node. It can be any sort of Ruby app, anything on a website, anything that you can get to by a browser can be tested with Selenium, mostly. You don't have to use any particular test framework. In other words, the Selenium adapter just handles the Node to browser communication. You can use it with TAP, you can use it with Mocha, you can use the native assert system, any sort of server-side test framework you want, as well as, of course, if you wanted to be in Ruby, in which case you're in the wrong room, any other sort of system you want in Ruby can be used with Selenium as well. There are a lot of things you can do to test front-end code. Phantom.js is kind of an up-and-comer. But what I have seen and felt for the most part is the systems that create virtual browsers, which is what Phantom does, or headless browsing, and tests under this headless condition have a lot of flaws, mostly which you're testing in an environment that your users are not using, and that browsers are notorious for creating flaws that where they run off the rails, run off their own spec, and those are the things you want to catch with testing, not the platonic. In an imaginary world with an imaginary DOM, this is what my imaginary website will do for my many imaginary users. Plus, it's tough to get imaginary venture capital. You can test any site with this. You can test a locally running instance of your site. You can test a remotely staged version of your site. You can test a live, real-time running site. You can test someone else's site. There's not many images in this presentation, so I put a cat in. This is the basic structure of a test running Selenium in the TAP, Test Anywhere, or TAP framework. You've basically, to maximize the test, I hid the requires, but WebDriver is required. It's presumed you've spun up the Selenium server on a separate console. So WebDriver remote will create an instance that you can use to send test commands through. You initialize it with parameters. There's some more work that goes into using Chrome, and I'll talk about that if we have some time or interest. But and any other sort of configurations you can send with to Selenium itself. And then you start the action by getting a URL. And this should open a browser, which you will see on your machine, to a given URL. I like giving it a little bit of timeout for client-side resources to spin up, for images to load, for anything else that needs to happen. And then here is the first case where you're actually communicating with the content of the page. Browser title will look inside the title tag of the head and will return the title as a string. And in this case, the site will have the title passive-aggressive 1248 for the title of the URL that I put in. When you shut down the tests, you basically quit, which will shut down the browser. And this is just a TAP construct, HP test end, lets the async manager of the testing framework know that you're done. Does this seem fairly transparent to people who've done this before? If you've ever seen the kind of overhead that, say, doing this in Java has, this is fairly compressed communication. There are some downsides to using Selenium in Node, much of which are just because you're using it, doing anything in Node. Because it's an inherently server-client communication, it's inherently an asynchronous communication, meaning everything will cause callbacks. Many, many callbacks. It can get very messy. You may be forced to execute several different steps to get a single thing validated. You may end up, your test may end up look like a lot of boilerplate copy and paste all over the place. And it may be difficult to look at a test and understand what is actually being done from a semantic level because of the immense amount of callback nesting. Most of these problems are manageable. One of the best ways to start managing them is using promises. Have you guys used promises before or are familiar with the basic concept?
Yes.
What a promise does is, instead of including a function as a parameter of a function, it uses the then. We won't actually see the result of it. You basically, let's skip ahead. Yeah. No, it's not. So you see there's a deferred object created by the Q library. You can do one of two things to pass data out from the end of a synchronous call. You can reject or throw an error out by passing an error into the deferred object, or you can resolve it, which means I'm going to return the expected result, and it'll be fed back to the test. And in this case, what I'm doing is I've got a library which I'm using to simplify one of the processes of Selenium's WebDriver API, which is for a given CSS element, I'm going to return the element which has information about a particular node in your DOM. And this is another example. Pretty often you want to see, is a DOM element visible? Especially if you have like an accordion layout. And one of the problems is that there's many things that may cause a DOM element not to be visible. It may not exist. It may exist but be hidden. And in many cases, when you have that situation, unless an element is visible and is not hidden, it will throw errors. Well, that's not really an error. It just means that a certain test condition. You may be actually expecting that as a test condition for an element not to be visible. So this is an example of writing a wrapper function in which, for a given browser, for a given element, either an element is visible, and I'm going to return a resolve of whether or not it's visible, or even if it's not visible, instead of throwing the error, I'm just going to resolve it as false. So these are the kind of helper functions you will write to kind of compress the long tail of a callback-based WebDriver system into a fairly simple function that you could call from anywhere just to get the result you want, not all the possible 5 or 6 variations of spin-out for the stuff that you don't care about. Like I said, there's a lot of situations where WebDriver's code will throw errors. When you write your kind of summary functions, you're going to want to catch those and just return to the user the upshot of the information and not let the system throw errors left and right. One of the big problems with the testing an interface is that the interface is just an expression of the data of your site, which may change all the time, and it's not really transparent how you test something when the expectation result is unknown. The best way to do that is you can the data that comes out of your REST APIs. There's a tool called Charles, for instance, where you can dump out an entire page's REST element as a folder of JSON, feed it back, whether through proxy, through, say, a mock element of your JavaScript, so that no matter what, when you look at a page, it'll always look the same. Another element of testing that's difficult, and this is just with Selenium, has nothing to do with Node, is it can be a pain in the ass to pick particular elements out of your page to test which. Get used to telling your designers this particular node needs a particular class, because otherwise your tests become pretty nightmarish to write and a real pain in the ass to test with. Yeah. This, by the way, this is an example of the visible in action with the promise structure. If you notice, the whole test is basically a linear call, return, then call, return. And you really skip out the nested insanity of callbacks. Using promises, basically you call your wrapper function, which returns a then function with an option abort if it actually throws errors. And then you can return a second helper function, and the calls cascade in a very nice, clean line, which you can see up there. I've got the URL to this if you're curious to see the source. Yeah. Some more detail on how you kind of mock out data. There's a lot of different places between your web page and your data in which you can intercept and substitute test data. You can go straight from your JavaScript to a secondary source under test conditions. You can branch certain URLs away from your server and onto a secondary server that serves test data or static data tests. Or the website itself can, when a certain element is flipped, pull data from a mock source rather than a real database. And you may find yourself surprising yourself that you've just written a cache system for your database that you end up using in production, which I've seen more than once. And part of the decision as to how you're going to mock your data depends on how much of the data is your data and whether or not you want to do things like running multiple tests concurrently. If you want to run 5 or 7 different scenarios, you can't have that data being served from the server level because it will never know like which test to return data for. If you want to actually test your live site, well, you can't actually serve mock data on a live site. So these kind of considerations are going to drive how you decide to mock up your data. And the third one, which is kind of a deal killer for everything, is do you rely on remote services like Google Twitter, all these sort of things. In general, I found if you want to test and you want to use remote services, if you have the luxury to, try to proxy them through your own server so that they appear to be owned data, because that gives you a lot more leverage to test shared or remote data sources, because they are effectively now your sources. Another thing that comes up a lot is time. I used to work for a site that serves financial data, so whenever you looked at a certain amount of data, the JavaScript was designed to pull today's financial information. Because it's especially interesting when you cache data and it turns out that somehow it ends up starting to serve tomorrow's financial information, which greatly increases your IP, but kind of screws your tests. There's a lot of different ways you can manage time in a test. The first is you force a certain time onto the web page. Say, today is January 1st, 2001. All of your UI should reflect that. The calendar should be January 1st, 2001. The graphs should go from December 2000 to January 2001, et cetera, et cetera. That's great if you've written all your JavaScript. If you're using shared components, it's a pain in the ass. And especially if your developers like to say, new date now. So if you're going to, on the client-side level, serve a particular fake date for your tests, you're going to have to spend a lot of time burrowing through your client-side code for any possible places where you directly pull data objects in order to get the current time. The second is you roll your data forward. And that was something I did for the other client, which is where we got a set of data from October 2002. Okay, I'm going to have all these financial transactions that starts from September to October. I'm going to find the latest date, which is today. I'm going to find the actual date, which is now. And I'm going to add that amount of time to all my transactions. So on the server side, all of these test cases are rolled forward to today. And that means you don't have to screw with your UI. You just screw with your data, and you advance the test expectations using a similar methodology. You just figure, what is the offset from test start date to now, and you add that to all the dates in your expected data. That works real well, but again, none of these things are maintenance free. None of these things obviate the requirement to really think about how you manage time in your application. The third way to kind of crack this nut is saying, I'm not going to use test data at all. What I'm going to do is I'm going to pull all the REST data manually using, I use the request library that Michael wrote. I'm going to pull in the REST data. These are my expectations, the data I just pulled. I expect to see the page reflect the same thing. You do kind of run into risk of race conditions, but if your data isn't changing by the second, you can create dynamic tests in which you're just comparing the user interface of your page to the pulled REST data you have required in your self-running test. That's another great reason to use Node, is because you have all these great libraries for pulling data from Twitter feeds, from REST sources, from all sorts of network sources, including, you can always, it's your database, you can pull your database and find out what it's pulled. You could even put a sniffer on all the data that comes out to a particular web page, fork it to your tests, and say, this is what I told this page. This is what you should see on this page. Because, it's got a great event system. You just, slap a listener on your running website, and away you go. I wrote a particular website to test a lot of the code I generated for this talk. All it does is list movies. And you'd be surprised how few good APIs there are for listing movies. Google has one that they say is no longer maintained, so thank you. But no, I found this site, I think TMS API, I think it's called. I'm not exactly sure the URL, but I'm basically grabbing these huge blocks of JSON, pulling them out into a Postgres database, and then just serving the movie listings you'd kind of expect to see. The two things I focused on for the tests are, there's this button interface. You can click on one of 3 cities, and then these buttons appear. Events, movies, etc. In this case, since I've only done the movie portion of it, there's only one possibility, which is Portland, Oregon movies. So and you also have a button. If you click on if you hit 3 buttons, click on the middle button, it reduces to that. There's a yellow button that appears. You click on that, you get your 3 movies back. This is the end product of when you've clicked onto a movie site. You get movies as buttons. The button explodes. You get 1 or more theaters with 1 or more times at 1 or more dates. And as just found out like last night at 9 o'clock, I fucked up the time zone conversion. So the movies were starting at like 3 o'clock in the morning and ending at 8 when you probably should be in bed anyway. Which made for some really good tests. Is that the end? Yep, that's the end. The tests I wrote are all in my Bingo Manatee GitHub account. You're free to go check them out. There's includes a system for how I pulled mock data out of a running page and stuffed it into a folder for later replay, and that sort of thing. Does anyone have any questions at this point? That's pretty much all I got. This is where you have to start answering the hard ones. All right. Yes?
Is there a particular Node database component that you would recommend? Like I've used Node Enhanced DB.
For recording test data, or for what particular?
Yeah, I load like dynamic content in there that ends up being JSON that is modified over time rather than just having static JSON files.
Well, in generally, what I do is I put all of my test cases as files, usually JSON files, and then I use a static web server for the stuff which is not time sensitive. For the stuff I have to modify, for instance, if you have a post function that you actually sub-select data, I basically read the text file in through the core file IO libraries, filter it down using underscore or some such. I use Moment for date management. Moment is incredible, and it works on the client and the server too, for date formatting, date advancement, date addition, all that stuff. I wouldn't store your test data in a database as such. I would store it in a test file as the sort of data which is the last step before you punch out the web server, which is usually JSON. Does that cover what you're asking? I mean, when I actually serve data, I've used Postgres, I've used MongoDB a lot. I've used file. My own blog is based on Markdown files and JSON file annotation because I've lost too many good articles because I got booted off of a shared server or it crashed. So my own content, this stuff I actually give a shit about, I store as Markdown files on a GitHub repo. Couch is very popular in the Node community. Yeah?
Have you had to encounter working with legacy services, web services like Surf or anything like that?
Fortunately, no. So now you can hear me. That explains a lot. I have not. Have you?
Not particularly with Node.js and Selenium much. A lot of it's much more current technologies.
Yeah. Sorry. Okay. Well, that's all I got. Thanks for coming. If you have any questions or comments, ask someone else, I guess. Good night.